So select Arduino Uno. This will be our second step. Okay. Once I have
This
installed the
software is
software,
open source, sir.
yes, sir, this software is open source. That why it is used mostly by the students for project works.
Okay, sir. Thank
Oh,
you.
even you can change the programs inside this software. It's a open source. You can make any changes. You can include any library. You can change the libraries even.
Okay, okay. Thank you.
Okay. After choosing the Arduino board, go to Sketchbook. After going to Sketchbook, you have to write down your program. Uh, for first program, we always do the blinking program. This is nothing, a simple LED which is connected to pin number 13 of Arduino board. We try to switch on and switch off that particular LED to learn the first program. Uh, so in this project, I'm using Arduino, our computer board, output transducer, which is nothing but our micro servo motor here, and input transducer. Here, input transducer is nothing but our Bluetooth, which is getting serial command from our Arduino. So you can say for input transducers, I'm using my Android phone. Inside my Android phone, I'm using sliders with the help of my thumb and changing the slider. Using sliders, those values being converted to digital values that has been passed to Bluetooth, and Bluetooth pass those information to my Arduino, and according to those instructions my motor changes. So this is my first program, void setup. Let's go to, and you can say, my software only. There we can learn better. Just wait a second. It is loading. It starts meanwhile. Okay. This is the page. Is my screen visible to everyone?
Yes, it is visible.
Okay. This is the page opens when I starts my Arduino IDE. You can see the first line is void setup, and second on line number 6 it is void loop. Any Arduino software consists of at least two loops. First loop will always will be void setup, where all the information regarding which are the inputs and which are the outputs are defined inside my void setup, and it always runs only once, because you don't need to define your inputs and outputs again and again. But whatever the program you want to execute over the Arduino board, you need to run it again and again. So all those instructions which we want to run again and again are defined inside void loop. For example, I need to measure the temperature of my room. So I need to measure temperature after every, say, 2 minutes. So I'm writing this program inside my void loop. So now I'm sharing with you the first program which we are using for our workshop. This is a micro servo motor program. First line say include servo.h. This servo.h is a inbuilt library which I am using, or you can say I am calling servo.h is a file which is being included in the library. I am calling it. And on the fourth line, I'm writing servo. My servo. My servo is nothing but a name I'm going to give to my servos. For example, I can change my servo to, say, guest servo. There will be no issues. But once I define some name here, I'm going to use that name again and again inside my program. So don't change name once you define that. On the line number 6, you can see integer position equal to 0. So I'm defining the initial position of my micro servo motors. For example, micro servo motors can rotate 180 degrees right or 180 degrees on the left hand directions. So I need to define where my cursor will be when I initialize my servo motors. You can give 0 degree or you can give 90 degree. It depends upon your project. You want to keep open or you want to keep close. Next, on the line number 8, the first three lines are your global variables which are being defined before your setup. Anything which is defined outside loop you can use anywhere. On the 8th line, my void setup loop starts. Inside my loop, you can see I'm attaching my servo to pin number 9. So pin number 9 is nothing, the distal pin of my Arduino 9 where my micro servo will be connected. You can give 0, 1, 2, 3 up to 13 because they are from 0 to 13, total 14 distal pins. You can give any pin which is free to be used. Now come to line number 12. My loop, which is the main function of this project, you can see on the first line I am using for loop, initialize with 0 because you can see at the start my integer value was 0. If there I have given value 90 and now I'm here starting with 0, there will be some errors because from 90 your servo motor will run to 0, then it will start changing. So please don't use different values for initialization and different value for loop. Please keep them same. So I'm changing the position of my micro servo motor from 0 say 180 degree, and for every for loop I'm changing by 1 degree only. If you want to change very fast you can say 5 degree or I can say 10 degree depending upon the project requirement. So but for example I'm starting with +1. Then what I'm doing, for loop will give first value as 0 degree. Now this position is being written to the micro servo motor. So micro servo motor will definitely go to +1. So from 0 to 1 degree. It will wait for 15 milliseconds. This command delay is for millisecond. If I'm writing 15, so delay will be 15 milliseconds. This for loop will keep on running with a delay of 15 milliseconds. If I want to have some larger delay, you can write 1000. It means 1 second. So after 1 second, the position will be 2 degree, then 3 degree, then 4 degree. It will keep on increasing up to 180 degree. Once I have reached to 180 degree, we will come out from this for loop. 1 second will be very high. That's why we have written 15 milliseconds. Similarly, once from 0 degree, I have reached to 180 degree. I want to come back from 180 degree to 0 degree. So in the second for loop, you can see I'm starting with 180 degree. I want to reach up to 0 degree, and now I'm decreasing value by -1. So same program, but once we are increasing the values and once we are decreasing the values. So we have checked this program for our project. So this is an inbuilt program. You don't need to remember it. You need not to mug it. Just go to examples. There are so many inbuilt functions like go to servo, go to SIP. This is the same program. Student can change this program as per his requirement. They can change the degrees, they can change the initialization, they can change the delays, they can change the pin numbers. uh, is there any queries regarding this program? Yes, I'm feeling I'm sitting with students, they don't reply.
So I think there is no query, so you can
Okay,
continue.
sir. Thank you. Now come to the second part. After micro servo motor, we are using Bluetooth. So this is also an inbuilt program we have used, and we have merged both the programs, micro servo motor and Bluetooth, for our requirement. Let's just open it. Okay, sir. This is the second program we are using. We are using character temp. So whatever Bluetooth is receiving from some device, it is storing that character in temporary folder, or you can say with the name temporary. We are receiving characters because the person who is transmitting you, he can transmit 0 1 2 3, maybe abcd, maybe comma, dashes, he can transmit anything to you. That's why we are saving in the character. If you are sure you are receiving only integers or string, you can change the type. Second, void setup, you can see pin mode 13 comma output. We have connected a LED, or which is inbuilt, you can say, and we are defining LED which is being connected to pin number 13 to output. You can see this pin mode and output is predefined words. You cannot change the way you write it. Output should always be in capitals. Pin mode only capital letter M. All other letters should be small. This is predefined. You cannot change. Second line, digital write 13 comma low. It says you are writing some digital data on pin number 13, and the word you are writing is low. So I am transmitting 0 volt to pin number 13, and on pin number 13 we have connected LED. So LED will be simply off. I want my LED to be in off condition when I am starting with this program. Next line is serial.begin 9600. This is to initialize the serial communication. Pin number 0 and pin number 1 digital pins of an Arduino is serial communication pins. So this line initializes the pin number 0 and pin number 1 with a baud rate of 9600. This is a predefined baud rate of any device. You can take Apple or Windows or any Android. So the initialization baud rate is 9600. If you want to change, you can change a multiple of 9600, 1900, 19200, and so on. But please keep it 9600 to start with. You can change it later. Come to the main body of the program. First, we are using while loop. First line just simply says if there are nothing we are receiving over pin number 0 and 1, please don't do anything. Just keep it simple. Wait. First line it is saying. On the second line, we are using if loop. This is simply saying if we are receiving anything on pin number 0 and 1, and that is greater than 0, so go to this if loop. So first to loop is to make sure you are receiving something on pin number 0 and pin number 1. Come to this line, temp equal to serial dot a. This line just reads the data which you are receiving through Bluetooth and converts it into word temp as a character. For this program, I'm just receiving 0 and 1. So if the character I have received is equal to 1, switch on my LED. If I am receiving 0, switch off my LED. So this is a very basic program to initialize the Bluetooth. If you are receiving 1, switch on the LED. If you are receiving 0, switch off the LED. So we are going to use this program for our micro servo motor also. So we are going to embed those both programs for our main program. So come to the next program, which is our main program, which are we using for, you can say, project. Let's wait. Program is just. So this is the main program. We have checked this program for our project also. It was working. We made some changes again and again. So we have to go back to the project again to see this program will work or not. We have to rectify our program based upon the speed and the weight of the arm. So you can see we are using again servo.h library. From line number 2 up to line number 7, we are defining 6 servo motors. 1, 2, 3, 4, and 5 and 6. Then I'm defining integer values like servo 1 position. On line number 9, I'm defining the current position, and on line number 10, I'm defining the previous position of the servo motor. For example, you want to move your servo motor from 50 degree to 60 degree. So 50 degree is your current position and 60 degree is your future position. But when you move from 50 to 60, so definitely 50 will be your previous position. So it will keep on changing. Speed delay, I'm defining 20. How fast I am going to change from 50 degree to 60 degree. So I have taken 20 millisecond. You can change depending upon your project requirement. I'm using index equal to 0. I will be using it in the program. The data I'm receiving through Bluetooth, I'm storing that data in terms of data in and read string. We will be using both in the program. So this is our initialization of the project. Then come to the setup part. In setup part, you can see I have connected my first micro servo motor to pin number 5. Again, servo number 2 is connected to pin number 6. Servo motor 3 is connected to pin number 7, and so on. We are using 10, sorry, we are using pin number 5 up to pin number 10 for these 6 micro servo motors. On line number 25, you can see we have initialized our serial communication on pin number 0 and pin number 1. So please do not connect your micro servo motor with pin number 0 or 1, because you will not be having any space for Bluetooth then. After initializing, I'm giving a delay of 20 milliseconds, and I'm initializing my micro servo motor with some predefined position. The position 90, 150, 35 depends what will be the initialization of your hand. You want your robotic arm in a vertical form, or you need 90 degree of your arm, for example, the 3 lower arms in vertical position and the next 3 arms in horizontal position. So depending upon the requirement of your micro servo motor, you can change the angles. It's better you can use 0, 0, 0, 0 degree, but we have used this position depending upon the hit and trial method. We were using these values for our project. Then come to the main program, void loop. Again, you can see I'm using only wide serial dot available. So definitely I have missed this part here. Definitely after that, if you are using your if loop, it will be much better. But if you are not using till it will work, but it will be prone to some error. If Bluetooth is receiving some data by error, it will initialize. That's why we always use two loops. Next, on line number 45, I'm giving some delay, because once Bluetooth is transmitting to you, it will take some time for the Bluetooth to receive all the data, and then the data will be stored inside the Bluetooth. If you are not going to give this delay, then data will not be received and you will start reading the data. So there might be some error. The data I'm receiving, I'm storing this data in the form of character, which we have studied earlier. You can see the data which are you receiving might be in the string form or in the character form, like 1 2 3 4 5 6 7. This line number 47 will wait till you are receiving data. Once you have received your data, so it will wait for the data to be end. So once your data is ended, you are not receiving any data, this will break from this loop. Okay, any doubts from these lines? We are using simple C language, nothing more than that. These lines simply says receive the data, wait till you are receiving the data. Once the data ends, store that data in the form of read string. That's it. Data can be of different lengths, but for this project, I need only first 5 bytes of the character, which is more important to me. So that's why what I'm doing is I'm removing all the other parts. We are interested bit number 0 1, so byte number 0 1 2 3 and 4. This 5 is excluded from the read part. Once I have read the first 5, I'm storing it in the name data in. Once I have received the string, I am emptying it using this empty read string. So I'm receiving data, I'm storing with the name of data in, I'm emptying the string which I have received so that I can receive further data. So I'm giving a delay of, you can say, 100 millisecond. You can give different delays depending upon the speed of your data connection between your Android app and your Bluetooth. If you are transmitting with a higher speed, you can give smaller delays. So once I'm receiving the data using MIT app, I'm transmitting my data in the form of S1, S2, S3, S4, S5, and S6. S1 means servo motor 1, S2 means servo motor 2. If my data which I am received starts with S1, so it is the command for servo motor number 1. So if it starts with S1, so the command is for servo motor 1. After that, first letter is S, second letter is 1. So those letter I already read that. I don't need them. So now I'm more interested in byte number 2, byte number 3, and byte number 4. So I am reading those 3 bytes, and after reading those 3 bytes, I'm storing those data into servo position. Now I'm comparing my previous position to the current position. If my previous position is greater, so I'm decreasing the values. You can see we are using simple for loop. If my previous position is less than greater position, I'm increasing the position of the servo motor. This is the same program we have used in micro servo motor. Now my current position I'm giving to previous position. That's it. I will be doing the same for servo motor 2. I will be doing the same for the micro servo motor 3, then 4, then 5, and then 6. You can see using only 2 simple programs of Bluetooth and micro servo motor, I can build this complex program. Just you need to work on the delays and the initialization of the angles. Other things are very easy to use. So this is all about the Arduino part. I hope at least something you learn from this Arduino part. If there are any queries regarding this Arduino part, we are there to help. Yes. I, ho I hope there is no doubts. So let's move to the MIT part. So this quick pulse width modulation we use in electronics. For example, we want our motors to have very high speed. We can give a duty cycle of 75%, where you will be transmitting more output. You are receiving more current or more power in the output circuit. If you are giving only 25% of a duty cycle, definitely the output power will be very low. This is the formula you can see for a duty cycle of 75%. If input voltage is 5 volt, you will be receiving 3.75 volt. If you are using 50% duty cycle, we will be receiving 2.5 volt. If you are using 20% of a duty cycle, we will be receiving 1 volt. If you are using, for example, DC motor, you want to have very high speed, we can give 75% duty cycle. But definitely motor will be more heat prone. So this is the instruction, like analog write 9, 128. If from 0 to 225 are the levels, so 128 is nothing but your 50% duty cycle. Similarly, if I'm writing 11.64, that means on pin numbers 11, I'm giving it duty cycle of 25%. So you can change this number 128, 64, 200 or 255 depending upon the duty cycle. Okay, so now the next part of our project is MIT App Inventor. MIT App Inventor is nothing, it is a free cloud-based service that allows students to make on mobile apps using block-based programming language. For computer science students, we don't encourage MIT App Inventor because they are having very good knowledge of, you can say, Java Studio. So they use to Java Studio. That's why they make their projects, Arduino projects, using Java Studio. But for a mechanical and electronic students or other department students, MIT app is more beneficial because we don't have to learn the complex programming. We can just use the blocks. Any MIT app will be having two parts, front end and back end. This is the front end of our mobile app. You can see these 6 motors. We have given name grip, wristwatch, wrist pitch, wrist roll, elbow. The next is shoulder, but by mistake I have deleted that name. And the last one is waist. So you can say motor 1, motor 2, motor 3, motor 4, motor 5 and motor 6. But for a mobile phone user, it will be very boring to use those names. So that's why we have written these names. At the top, you can see there are 3 names: connect, disconnected, and disconnect. We will learn what are these names in the programming part. This is the backend programming. In this project, maybe I will not be able to explain or all the programming, but definitely we are going to know what is the MIT App Inventor and how to use that. It might be looking very large program, but believe me, this is a very simple program. Just we need to give 2 2 or 3 hours we can make this code. So we are moving to the MIT app. This is the front page of an online MIT app inventor. Just go to this create apps and this page will open to you. You can see these are the projects made by me. They are available online. I can use them anytime. And just I'm opening my, this is the front page. Where I define what will be the things which will be visible to me on my mobile phone. At the top right, you will see there designer and blocks. Go to these blocks. There you can see the block programming of my code. So this is the block programming we have used for our project. So we are going to learn a simple programming. We are starting with our new project. Say webinar. Just go to the projects, start new project, give some name to the project. Webinar. Just open it. Okay. You can see this is the front page which will open to you when you will start the project. This is a blank project. This front end consists of 4 vertical windows. First one is palette, second one is viewer, third one is component, and fourth one is the properties. Viewer is the part which will be visible to you on your screen. So just drag it down, go to this palette, go to this layout. Here you can see horizontal arrangement and vertical arrangement and table arrangement. These are the arrangements. For example, you are choosing some buttons. You want to arrange those buttons horizontally or vertically, you can choose that arrangement. For example, I'm taking horizontal arrangement and I'm dropping this horizontal arrangement to our screen. After that, I'm going to this user interface in my palette. From here, I'm choosing this label. Pick this label and drop inside my horizontal. So change this name of label through properties like Manav Rachna University. Like you can give any name. I have given name Manav Rachna University Webinar. So you can see the name will change. Manav Rachna University Webinar. Now the width of this label is automatic, but I want to change it. So go to this width and inside percentage write down 100%. It will cover 100% of your width. Now you want alignment of the label at the center, so choose center. So you can see Manarachna University webinar at the top, you can see. So this is the same which we used for project. There we have written as robotic arm. So you want to have these things in bold, so you can bold. You can change the width of the latest Manashna University. It's up to you. Again, go to layout. Again, choose horizontal arrangement and drop inside the screen area. Now, go to the Bluetooth list picker. This one list picker, just pick it, drop this list picker. After that, choose this label. I want this label inside my horizontal arrangement, so I have done it. After that, I need a button. Just pick a button and drop it. So change the name of the list picker. Just select it. Go to the text and write it. Bluetooth list. You can see on the screen the name of the Bluetooth list is Bluetooth list, but in the component part you can see it's still showing list picker. So you may be confused by list picker and Bluetooth list, so you can change both name. Inside component at the bottom you can see the name rename. Just rename it. So it will be easy to program if you are having same name. For the label, change the name it to connected. Similarly, for the text button, I need name disconnected. Name it disconnect. If you want to disconnect your Bluetooth, telling I'll change. Okay. Similarly, for connected, I want to change it in the text also. If you are using the same name, it will be better or easy to program. So you can see the second line width changes. So you can do is change the width of each and every, like for Bluetooth, use, because there is a 100% area, so you can use 33% area for each block. That's it. So you can see Maharashtra University webinar. First list the all the Bluetooth devices which is being paired with your Bluetooth device of your mobile phone will be visible inside this list. So this Bluetooth list will show all the connected device or paired devices. Once you have paired with some device and selected that device, this connected button will show is it connected or not. If it is in red color, it will means it is disconnected, and disconnected word changed to disconnected. If it is in blue color and it is written connected, so Bluetooth device is connected to your mobile phone. But once it is connected, you want to disconnect that particular device, you will press this disconnect button. So you can see using these small properties, we can design the front end of our app. So you can see in the connectivity part, there is a Bluetooth client. So please pick this Bluetooth client and drop over. It will be available inside the backend programming. So similarly, you can do all the programming. So I'm not making a complete project. It will take 2 to 3 hours. So just I'm giving you the demo how you can use your project. You can build your project one by one block. So now come to the backend programming. So it is very simple. Like I have chosen Bluetooth client. So you can see on the Bluetooth client, there are number of blocks which you can use depending upon the requirement. So before that, go to Bluetooth list. There are two buttons like after picking. and again before picking. Okay, then go to your like logic. You can use like this button, true, false, not, equal to, same. For text, you can use this button. So you can join these buttons as per your requirement. I'm going to my main project. There I can able to show like you can see on the first line list. Go to list. This is the same button I have used. Then again go to the Bluetooth list. You can use this one. You can see again this Bluetooth client is nothing but your Bluetooth. Go to this Bluetooth client, sorry, and from here you can choose address names. This one, and this block is completed. So this way we have practiced these programs after watching hundreds of videos or hundreds of projects. After that we were able to build these small programs. Once you replicate some projects, it will be very easy to use these block programmings. It will be very difficult if you directly go to the project or say I'm going to build this project by my own. No, first replicate some projects. If you are able to replicate those projects, then you know what you have to do, because the steps for Bluetooth connection will be same. It doesn't matter which project you are making, it always going to remain same, but the requirement of the project will be changed. So that's it from my side, JP sir. For any queries, I'm there. Any doubts from any guest?
If anyone have any doubt regarding all the content which was shared with you all, you can mail us so that we can answer their queries after the webinar also. At the end of the webinar, we share you all the details regarding contact of with us through mail. Okay. So if anyone had any query regarding all the content which was shared by Vijay Gill sir, you can ask right now or after the webinar also. Sir, I think there is no query right now.
Okay, thank you sir. You can now share your PPT.
Okay. Thank you. Thank you, sir, for the presentation. Now I am going to share my presentation on robotics. The coding part and was already shared by Vijay Gill sir. So I'm going to start with my presentation. So the today webinar topic is regarding a webinar on robotics and automation. The automation part is related. We can perform this with the help of several things, with the help of servo motor, with the help of pneumatics, and with the help of hydraulics also. But for today webinar, which is going to be an introduction based, so with the help of servos, we automate our robotic arm for performing a pick and place operation with the help of robotics. Okay. In today webinar, I'm going to cover the basic introduction with robotics and the different principles which was given by different people, with the help of which we can calculate the position of tool or the position of our links with the help of forward and inverse kinematics. Okay, so with the introduction, uh, as per the definition of robotics, it is a general purpose programming machine which performs certain anthropomorphic characteristics. The basic idea behind developing these robots is to perform several operations that may be hazardous to us, that may be repetitive to every person. Suppose if a operation is to be performed for 1,000 cycles, so with the help of robotic arm we can perform the same operation at a better accuracy and at a faster rate also, for consistency and accuracy, which is the major objective for creating these robotic arms. There are also several areas where it is very difficult to do any task by humans. So with the help of robots, we can do such operations. Also, the restriction with the human being, that he or she can perform a shift with respect to the operations. So with the help of robotic arm, we can perform multi-shift operation. Any operation that can be done with the help of robotic arm, that can be reprogrammable with the help of certain programmers. There's also such robot available within the market that can perform multiple tasks with same configuration. So this makes the robotic arm flexible. At last, all the robotic arm can be interfaced with the help of robot computer. So in such a way, we can control a robotic arm from far away also. So with respect to these advantages, the benefits of robotic arm are much more. Now, this slide represents the first robotic arm which was built and called at that time as a Unimate. This was developed by Joseph in 1956 around, and George. So these are the two persons who developed a robotic arm that can pick and place a component from one location to another. After this development, the major application of this industrial robot was done by General Motors in 1969, which changes their whole production facility up to 40 to 90% with respect to spot welding, and they installed around 3,000 robots by 1973. So, in such a way, the development and the application of robotic arm takes place in the market. Now, with respect to the robot, it contains some anatomy with respect to its assembly configuration. So, whenever a robot is going to be manufactured or created, there are several things which are within the robotic arm, such as whenever we are going to join two components, it create a joint which perform or which provide a relative motion with respect to each other. While joining these different joints, we can make any one with respect to of these link can be rigid or movable. The various motion which we can perform with the help of these robotic arm are linear and rotary with respect to its restriction of length. Whenever we join two links, it provides a degree of freedom with the help of which we can perform a particular task. The maximum number of degree of freedom that can be possessed by a robotic arm is 6. Now, if we are going to divide a whole robotic assembly, it is divided in two parts. The right hand side which you are looking right now is the body and arm configuration, because it only contains the links with the help of several motors or servo motors. Now, if we want to perform any task with the help of this robotic arm, we need some end effectors. So that comes under wrist assembly, with the help of which we can perform a particular task. Okay. Now, if we are talking about different configurations which we are available in market, or with the help of which we can perform several tasks. So there are five types of configuration which are available in market. The first one is polar coordinate body and arm configuration. The downside image shows the example of this polar coordinate body and arm configuration, which has a base, then has a rotary motion over here rotary motion, then again a prismatic joint with the help of which it can perform a translatory motion. This is the first type of configuration of body and arm robotics. The second configuration is cylindrical body and arm assembly. So this is an example of this configuration. So in such a way, Cartesian coordinate body and arm assembly. So this is an example. So all these configurations which you right now looking are combination of some revolute or some translatory motion, based on which the action they perform, these configurations are named. The other is jointed arm robot configuration. So this is the example of jointed arm robot configuration. And last one is SCARA robotic arm configuration, which is selective compliance assembly robotic arm. Basically, this contains has a four links with the help of which they can perform a 4 degree of freedom operation with the help of an end effector. So these are the different configurations which are available in the market, and based on which we can attach our different end effectors with the help of which we can perform different tasks. So these are the five different configurations of robotic arm arrangement. Now, the different types of motion which we can perform or which we have to know while creating a robot. So there are two types of motion which we can perform. The first one is translation, and the second one is rotary motion. The first one under translation motion is linear joint, and the notation which we use is called L type. So this is the first type, which is a linear joint. The second type is orthogonal, and with respect to linear joint, whenever a motion is going to be performed with respect to translation, the axis of both links are parallel while performing any action. With respect to orthogonal, that link to axis with respect to performing an operation should be perpendicular to the primary axis or the input link. So these are the two type of motion that we can perform in translation motion. The second category under is called rotary motion. The first category is rotational joint, and the notation which are used for this motion is R type. So while creating a configuration, these notations are used for creating these motions. So the for rotational joint over here, this is the example of rotation joint where two links are attached, and with respect to the primary link, the second link can rotate at the common axis. The next is twisting joint. So with respect to this is the notation which we use for this twisting joint is T type. The difference between rotation joint and twisting joint is that the rotation joint can't perform a 360-degree operation. So with respect to a twisting joint, it can perform a 360-degree motion with the help of which we can complete or perform any operation that contain such type of motion. And lastly, the revolving joint motion under rotary. So with this, it can perform a 360 rotation, but the working axis should be perpendicular to the input links. So these are the different types of notations that we are using while creating a robotics. So earlier, whatever we study or whatever we saw within the slides, all those motions are shared with respect to the different links which are combined for the robotic arm. For performing any operation, we need some end effector, and that comes under wrist configuration. So there are three types of motion that we can perform with respect to a wrist configuration. First one is rolling, second one is pitching, and third one is design. So with respect to the configuration which was shown right hand side downside, so the rolling action should be along rotation along the normal axis, the in such a manner. So if this component is going to rotate clockwise and anti-clockwise, so this is the rolling motion. If this motion is going to be performed at this point, so this is called pitching. The component can move up and down and have a R joint in such configuration. And lastly, the yawing part, which involves the motion of left or right rotation. So over here we also use a R joint. So these are three motions that we use for performing any end effector operation. I think someone joins. Sorry for that. So this is the wrist configuration. Next, so in earlier side, the basic introduction to robotics was completed. In this slide, I am just showing a development which was shown by a company AMR, that is called automatic mobile robot. So this is the application part of robotics, where they can produce different series of robotics, with the help of which they can perform several pick and place operation. Also, in the downside image you can see that if you want to arrange a certain specific size of package or certain specific weight of package, so with the help of these robotic arms you can perform such operation without interference of human being and efficiently. So this is just I'm showing an application of robotics arm. There's one more application. While segregating components on a conveyor belt, we can perform such robotics with the help of with the use of camera, and we can also add AI based learning and vision system, with the respect to which our robotics can be converted into a smart robot, with the help of which we can segregate or sort a certain number of components that can be passed through a conveyor. So this is the just application of these robotics. Now I'm going to share you a little theory behind the robotics while you are creating, because at last what we have to do, we have to find out the final tool position with respect to a robotic arm. So with respect to that, there are few things which we have to know. So the first thing is that principal axis rotation. So whenever a link with a servo motor is assembled, so there are three axes which is called as principal axis. So XYZ over here you are seeing, this is called principal axis. So when we are going to perform a rotation about Z axis, so the new frame which is going to be created is UVW. The W is written on the same axis because the rotation is going to be performed on the same axis. The new axis which are generated after performing the rotation is called U and V, and the angle by which they take rotation is theta. So these are two frames basically. For evaluating the final position of tool, we consider these different frames, and with respect to a body arm, we are the principal axis rotation or principal axis frame. With respect to an end effector, we have a Euler angle representation. So with respect to that, that is maybe a movable axis frame. So if we want to calculate or if we want to perform a rotation, we have to calculate or we have to perform such operation with the help of matrix that can ease our analytical part. So the next time which you are looking right now is the top view of the rotation which we perform, and the different notations or principal axis which are shown on this. So the x vector or cap you are looking at, this is the dot product of x cap you are looking right now, is basically the component of the axis, and u cap is the unit vector. So the dot product of this is showing as a cos theta. So we are and every axis has a unit vector and a component. So over here the dot product you are looking right now, x cap and u cap. X cap basically is the principal axis over here. X cap is written over here, and u cap basically is the new frame which is achieved over here. Okay. So for writing these changes in a matrix form, we just evaluate or match with the two frames. So for getting this frame, what we have to do, we have to write over here x, y, and z. With respect to that, u, v, and w. So with respect to the motion which was performed over there, so over here, if you want to looking at u is here and x is here. So the change which was taken place after performing a rotation by theta is theta angle. So over here we use theta. With respect to v axis is here. So the new the change which was taken place, that is 90 degree from this, and the change over here will from this for this v is theta. So the total angle which was covered after taking rotation is 90 plus theta. So we written over here 90 plus theta. With respect to the w axis, the angle between the x and y axis is 90. So we use cos 90. So in similar manner, we can write by comparing the different axes or the principal axes, we can write this matrix. So in such a manner, this matrix is generated. And for the final matrix which we got after performing the convergence with respect to cos 90 minus theta is sine theta over here. You can see, and cos 90 plus theta is minus sine theta. So you do not need to calculate every time this conversion. You have to just remember this rotation matrix, because whenever a robotic arm is going to rotate, we have to see that around which axis the rotation is going to be taken place. So this is the rotation matrix which we have to remember, as a robotic link is going to be make any rotation about any axis. So in similar manner, the rotation matrix about y and x are also evaluated. Okay. So I'm just showing an example. If rotation about y and rotation about x is going to be happen, so in such a manner you have to evaluate the final position of a principal axis. Principal axis means the x, y, z axis at where it is going to be reached. So in such a manner you can perform the rotation. Basically whatever I am telling you right now is the uh, theory behind robotics, which with the help of which we can calculate the final position of our tool position. So in such a manner, so basically the rotation matrix right now you are getting over here is just telling the rotation, but at the same time a robotic and kinetic arm can perform a translation also. So with the development of theories, there the homogeneous transformation matrix was generated, with in which there are four things are assembled. So this is basically a homogeneous transformation matrix. In this, the first part over here, the top part, the actually this matrix was divided in four categories. So the first part is rotation matrix over here. At the same time, if a link is going to perform a translation, the this is translation matrix, and the configuration of the rotation matrix is 3 into 3. Okay, the configuration of this translation matrix is 3 into 1. Right here at the corner of this 0 0, it shows a perspective matrix which is related to the vision system if we are using. And at last, if we are going to perform an scaling factor, we have to use different values as we are performing scaling. But in case of robotics, whatever the configuration of practical model and whatever we are simulating, it is going to be common. So in case of robotics, we always use the scaling factor of 1. If we are going to use a vision system, then these values are going to be changed. So for collaborating all these four operations, that is rotation, translation, and vision system and scaling factor. So in such a manner, a complete 4 by 4 matrix is used for evaluating the final tool position of our robotic arm. So this is basically called as a homogeneous transformation matrix. Okay. Now this is a principal axis frame. I'm just showing this slide because if you are going to perform a rotation, that should be in a reverse order. So the final of the position of that component is not going to be same. So while evaluating the final tool position of a robot, you have to be precise that what configuration or what path you are going to follow. Over here, these two transformations are shown over here. So this is the sequence of transformation. Over here, this is the first transformation. So what I have happened over here, we perform a rotation about z axis. Then after perform a rotation about y axis, the final position of object is going to be reached in such a manner. Now if we are going to reverse the same sequence for performing the transformation, what happens? See, you can see over here, the initial position of the component in such a manner is placed. Now if we perform a rotation about y and then perform a rotation about z, so at final stage you can see that the position of object is going to be not matching. So while performing any rotation or performing any sequence of operation for getting the final tool position, you have to be precise that what sequence you are going to follow. Okay, so this slide only shows the difference between the sequence which is going to be followed for getting the final position of a component. Okay, now uh, there are more theories come that if you are going to perform a rotation with respect to a body and arm or an end effector, there are two representation schemes placed. The first representation is, these representation scheme are just showcased to create a difference between the body and arm and the wrist configuration on a assembly. Okay, so while performing a representation scheme with respect to the body and arm, this is the representation scheme which was used. This is xyz fixed angle rotation. So while calculating the rotation with respect to a body and arm configuration, uh, behind the end effector, whatever the assembly which was created with respect to the robotics, it is called as the body and arm configuration. So for that you have to follow this fixed angle representation scheme. And with respect to the end effector representation, you have to follow a Euler angle representation. So in the transformation you are just looking over here, there is a principal axis and rotation at a single axis must happen at a single time. So in the first diagram A, the rotation is going to be taken place about x. So due to which there is a change in y dash or w dash, the new frame was achieved. After that, the rotation takes place about y. So the changes as a u double dash and u double dash. In the similar manner, at the final, the rotation takes place about z. The value of which was achieved is uv w. So to follow this representation scheme for xyz a body and arm configuration, so showing an example that for getting the final transformation matrix, you have to perform a rotation. So if you need to calculate the final position of and sequence which followed by the in such a manner that is xyz a b c, so the final robot in terms of rotation we calculate. Okay. This is the final transformation matrix which is 3 by 3. So in such a manner you can calculate the final rotation of, you can find the final rotation values of your robotic arm. Okay. Link pitching AI concept RPY. Now with respect to the end effector, there is another scheme which was represented, that is moving frame. So with respect to a body and arm, you have to follow the XYZ representation scheme. But when you are going to calculate the tool position or performing any rotation with respect to the end effector, you have to follow the Euler angle representation scheme. So these are the two representation scheme which was used for calculating the different motion which was going to be happen with respect to body and arm or with respect to a end effector. The difference between both representation scheme is only that the sequence of rotation. In case of xyz representation scheme, we use uh, we use this xyz. It means in case of Euler angle, we use 1 2 3 or wuv with respect to XY condition, we use XYZ. So the sequence of rotation is only different. Otherwise, the same manner. Okay, used for finding final with respect to a rotation which is going to be performed with respect to end effector or with respect robotic arm. Okay, now these things, if we are going to consider link, so there may be a term called mapping. What actually it defines is that if a frame is someplace, suppose I'm going to create frame. So suppose we are going to consider this XYZ frame, X, Y, Z. These are three principal axes. So if and over here they created this is a cylindrical good basically this cylindrical arm, and somehow the rotation is going to be happen in suppose rotation is going to be happens by 30 degree. So there is a possibility that the final position of this cylindrical arm is going to be happen over here. Okay, in such a manner. So with respect to this, the new frame which is going to be generated over here is in such a manner. So U is lying over here, V is here, and W is here. So you can see that by performing a rotation, there are two principal axis frames are generated. First one is XYZ, this is the basic principal frame, and second one is UVW. So for correlating these two different frames, if and a point if lying is in such a position, so if we want to project this point from frame UVW to XYZ. So for performing such things, we need mapping. So there are three possibilities that can be created with respect to a mapping. What are those possibilities? So this is the first possibilities. Uh, the two frame can rotate with same origin. So the first diagram right hand downside is showing is the rotation about same origin. The second configuration which is going to be happen with respect to the mapping is that the second frame can be translated by a certain distance. So the second frame UVW is going to be translated from origin O1 to O2, and the uh, third configuration that can be created that after performing a translation from position O1 to O2, it can perform a rotation about the same origin of O2. So these are three things that can happen with respect to a robotic arm for considering the different principal axis frames. So mapping is the part which can help us for correlating two frames that may be translated by a distance, or there may be a rotation at the secondary frame. The secondary frame is over here UVW. So for correlating these changes within these two different frames, we use mapping. Okay. Now there are two people that David and Hartenberg. So if you have a physical link of a server motor, so getting the axis with this physical setup, they provide few rules. So they these four rules are used for creating the principal frame to a physical setup. So the first rule says that the whatever the axis of rotation, that the second it says that whenever you are going to create a x-axis, that must be a perpendicular to 90 degree with respect to a z-axis. The third rule states that you have to follow a right hand thumb rule for creating the y-axis. So with the help of these three rules, we can create the with respect to a uh, but the last rule states that whenever you're going to create a x for the next servo, so there may be condition that the x-axis must intersect the z-axis of the previous frame. So these are the four rules which was offered by David and Hartenberg for creating these principal axis frame with the help of a for a servo motor, for a robot with a servo motor. Okay. So I'm just showing an example over here. So how can you find the principal axis frame if you are going to create a robot that use a servo and a link? So over here you can see that this is a servo and this is the link. Okay, so this is the servo and this is the link, and the dimension was represented with respect to a1 and a2. So with respect to right hand thumb rule, when you are going to perform, whatever the axis or whatever the axis of rotation, that must be the z axis. So over here when you are going to create this diagram, so this must be the z axis. Now if you are going to follow the second rule, that the x axis must be perpendicular to z axis. So this is the x axis. So over here you can see that the 90-degree angle between these two axes. And the last rule states that you have to follow the right hand thumb rule for creating the y axis. So when you are going to put your palm in such a manner, the thumb represents the z axis and the finger represents the x axis. You have to create the y axis in such a manner. So while creating a y axis with respect to a practical configuration, you have to follow the right hand thumb rule for creating this. Okay, so DH frames are used, or rules are used for creating this principal axis frame for a physical setup. Okay, so over here you can see that this thumb represents the z axis, and the few slides I'm just showing the rules which I already covered. So this is the z axis. So over here these two servos are placed. So whatever the axis of servo, that must be the z axis. Okay, now sorry, now these are the first rule. Now the second rule states that the x axis must be 90-degree to the first axis. Okay, so the x axis you can see over here, the perpendicular to 90-degree and to z axis. The third rule says that you have to follow the right hand thumb rule for creating the y axis. So in this, y0 is created over here, and with respect to the this frame, the y axis is going to be created over here, y1. Over here you can see that the fourth rule states that the x axis must intersect the z axis of previous frame. So over here, when I'm going to extend the x line backward and this red line upward, over here you can see that these two axes intersect at this point. So these are the four rules which were offered by Dynavit and Hartenberg for creating a principal axis frame with respect to a physical setup, with the help of which we can calculate the final position of our tool. So before creating any robotic arm, if you have a basic knowledge of these norms, with the help of which it is very easy to calculate the final position of our robotic arm. Okay, so these are the few rules which are going to offer. So rule 3 states that you have to follow the right hand thumb rule. So by placing your right hand thumb, you can find the y axis direction. Okay, so in such a manner we can create our y axis. Okay, now the fourth rule states that the x-axis must intersect the z-axis of previous frame. So I already share this, that how you can do that. So over here you can see that the z-axis intersect the x-axis of forwarding frame. So these are the four rules with the help of which you can find the principal axis frame of any robotic arm configuration. Okay, now DH also provides one another rule. uh, Suppose you have two different configurations. So with respect to that, I'm going to previous slide. So over here you can see that for calculating the final tool position, we have to follow rule offered by Dynavit and Hartenberg. So in the same manner, if you are going to perform this, if you are going to calculate the final tool position with the help of a software, what you have to do, you have to move your previous frame, that is x0, y0, z0 frame to x1, y1, z1. So you have to move in such a manner that this x0, y0, z0 frame matches with x1, y1, and z1. So this is another few rules which are offered by Dynavit and Hartenberg, with the help of which you can correlate two different frames which are generated with respect to two different servos. So this is the rule which was offered by Dynavit. So if you are going to do that thing, that you have to match the x and z axis with respect to the forwarding axis. This is the forwarding axis frame, and this is the starting frame. Okay, So what you have to do, you have to perform four operations. What are those operations? The first operation, you have to perform a rotation that about red axis over here. So it matches with the common normal. This is the common normal. Okay. Now after that, what you have to do, you have to make a translation out along that axis with respect to this. This first frame is going to matches with this intermediate frame. After that, you have to perform a translation along the common normal. So this frame, intermediate frame, is going to reach over this final frame, forwarding frame. And at last, what you have to do, you have to perform a rotation about x-axis with respect to which this z-axis is going to be parallel, a line which is perpendicular to the common normal, or this line may be the red axis of second servo. Okay, so these are the four operations you have to perform for finding a for moving the principal axis frame of one frame to the next frame. So if you are going to do the same thing again, it may be a very tedious task. So they provide a homogeneous transformation matrix with the help of which you can ease your analytical tasks. Okay, so this is the homogeneous transformation matrix that we can use for calculating the transformation from one frame to another frame. Okay, I'm just showing an example. Over here you can see that if you are going to perform a transformation with respect to two different frames. Okay, okay, over here right now. So we have four matrix. Okay, so the operation which we performed in the earlier slide, that is rotation with translation red and green axis. This is about red axis. So these are the four matrices, homogeneous transformation matrix with respect to our transformation we take over here in terms of DH parameters. DH, what are DH parameters? DH parameters basically dynamic and Hartenberg parameters. So if you are going to multiply these transformation, the final matrix which we got over here is this one. So if we are going to perform two different tasks, that is on the first frame and then on the second frame, and then we are going to multiply, we found the same matrix which is similar to the transformation which was performed one by one. So in such a manner, the basic rule which is going to be followed for getting the final homogeneous transformation matrix and the rules which was offered by Dynamit and Hartenberg gives the same output. So this eases our task if you got a 3 or 4 servo motor configuration with the help of which you are going to perform a particular task. Okay, now I'm going to show you an example. uh, there's a configuration, there's 2 degree of freedom configuration. The first motion which is going to be performed in this diagram is revolute over here, and the second transformation which is going to be performed over here, translatory. Okay, so with the help of DH, we have to find these 4 different parameters: the joint offset, joint angle, link length, and twist angle. Okay, so when you are going to find the rotation and translation values with in terms of these different parameters, so we have to create a table. So over here, joint represents a frame which is going to be created at this base frame, and the second frame which is going to be created at this prismatic part. So we have to find these different 4 values in such a manner. I'm not going to explain how we are going to find this. I'm just showing that how you can do this. Okay, so you have to know or get the information that how you can find these different parameter values. So after getting the joint parameter of DH, what you have to do, you have to fill these parameters in this homogeneous transformation matrix which was given by DH or Dennevit Hartenberg. After that, what you have to do, you have to put those values in the homogeneous transformation matrix which was given by DH. So we got a homogeneous transformation matrix of this for this parameters, and the second homogeneous transformation matrix for these parameters. After multiplying these two matrices, what you got a homogeneous transformation matrix which represents a point P which is lying in second frame and we are projecting on first frame. Okay, or zero frame, sorry. So after multiplying, we got a homogeneous transformation matrix. So So why we are doing this? Basically because I'm going to tell you one thing again. Why we are doing all these multiplications and following the DH parameters? Basically we have to perform a particular task with the help of this configuration, and an end effector is going to be placed over here. So for finding the accurate value of this position, what we have to do, we have to make certain changes with respect to this theta variable and this translation variable d2. So for getting a iterative task, for saving our time from iterative task, what we have to do, we found a common matrix. What was the common matrix? This one was the common matrix with the help of which we can find the final or accurate value of our tool point by changing the variable. What are those variables? The variables are theta1 and the d2, the displacement or the translation which is going to be performed for the second link. Okay, so in such a manner these DH frame rules are helpful to us for finding the final tool position. Okay, so over here the variables which we took are theta 1 is taken as 120 degree, and d2 or displacement is taken as 200 millimeters. So if we are going to put that value on the homogeneous transformation matrix which we calculate analytically, this was the result. Okay, now there's another software which was developed by IIT Delhi, that is Robo Analyzer, which is free of cost right now and open source. So you can download also that software. We are planning a next webinar on that software, uh, with in which we are going to teach how you have to calculate these different four parameters and how you can validate your analytical result with the respect to your software. So over here the downside image you are looking right now, actually the DH parameters we calculated and the variables over here are written. We fill those parameters in the software, and the result you are looking after here is similar. So in such a manner, if you are creating a robotic arm, you can validate your result in terms of these parameters. Actually the software took the values in meter. That's why this 100 value written over here, and over here the 0.1 value is written over here. This is translation value, and over here you can see that this is 0.173 and this is 172. So the difference only comes over here because in software the translation values was taken in meters, and but in the problem statement it was taken as millimeters. So if you are going to create or design any robotic arm, so with the help of a software you can perform this action. Also I'm going to show you those interface of software with respect to screenshots also in the presentation, and with respect to software also. Okay, so basically this is the interface of that software. Okay, there are few setups that you can perform with the help of this software. You can perform a forward kinematics, and with the help of inverse kinematic also. There are different configurations which can be generated. With respect to a problem statement, we have a 2 degree of freedom configuration, and we have a RP type robot, that is revolute and prismatic. Now the DH parameters which we calculate with in terms of these parameters, after filling we click on forward kinematics, and the result which we have to calculate in analytic manner, we got the same configuration of end effector configuration. Okay, so what actually it tells us, it actually tells us the final position of our end effector by making these changes in the link rotation or translation with respect to a prismatic joint. So in such a manner, if you are going to create a robotic arm with the help of this software, you can find the final accurate tool position of your robotic arm. Okay, uh, I'm going to show you the interface of that software also. Basically this is a robot analyzer software. Okay, I'm not going in detail in today webinar. I'm just showing a few changes. If you want to make a change in 3 degree of freedom, and if you want to take a PRP type, that is prismatic revolute and prismatic joint, and after clicking over here, you can see that in a moment the configuration is going to be changed, and the DH parameter is also is going to be changed. Now if you are going to calculate on forward kinematics, okay, and then if you want to trace the tool point, so in such a manner you can see the that how the tool is going to be perform a particular action, and also you can get the end effector position in terms of accurate values. So in such a manner you can find these tool position in accurate manner. We are planning a second webinar in terms of this software. So the next thing is that we are just right now whatever we have done is forward kinematics. We can also perform inverse kinematics with respect to our robotic arm, because it is important, because at every time you don't know the tool position which is lying in space. So if you know the position of an end effector and the link length of each link, so you can find these joint variables, that is q1 q2. Basically these represent the theta 1 theta 2, with respect to which we can find the final two position. So in terms of inverse kinematics, what we have performed, we have to find these q1 q2 if we know the tool position with respect to a configuration. So this is a 2 degree of freedom, two link configuration. The 3 degree of freedom, 3 link configuration. In these cases we already know the position of tool p. So we have to find these q1 q2 q3 parameter. So if we are going to do this thing, then it is called inverse kinematics. I'm not going in deep with respect to this. Now I'm going to showcase the model which we have performed. Actually, due to COVID, the campus is not open, so due to which I'm not going to, or I'm not able to show the 3D model. I'm just sharing a screenshot. So this is basically a robotic arm which we created in the software. That this is the base, and the different servos also located over. There's a servo over here, over here. There's another servo which was placed on the base of this thing. The servo is placed over here, and this is also a servo which performs a rotation with respect to the end effector. Okay, this is end effector which was created in this robotic arm for picking and placing a robotic picking and placing a component from one location to another. So we created this 3D model in the SolidWorks software. Now we also have a 3D printer, which is very useful to us, because if we have an idea in our mind, if we are not able to physically see that idea, so it is very difficult to find the pros and cons of that model. So we put each and every part in our 3D printing software. Then we take a 3D print of that components, and after that we assemble each and every component with the help of servos. Okay, we have two software with respect to a 3D printer. We have a collaboration with our Altair firm, there is a software called 3D Print, which is very useful for changing the different support which was taken by component. We also have this Cura software, with the help of which we can create the GN codes for creating, which was accepted by a 3D printer actually. Okay, I'm just showing the interface of this. What is the advantage of using this 3D printing software? Basically, there are different materials with the help of which you can print any component. Okay, so there are few settings that you can change with the softwares. Okay, these are the materials of bed and nozzle. If you want to change component, then you can change this 50% or 25 times, 30 times, which is going to be 3D print. Okay, so this is basically the component which are in the 3D, and it tells what amount of material which is going to be consumed, and what amount of material which is going to consume, and time which is consumed by the printer to print that component. So with the help of this software, we get the logical data that what amount of material and time which is consumed by the 3D printer to give our final product. There are few tools with the help of which you can perform several things. These three tools are placed in the 3D printing software, that you can perform a rotation, because every time we print, there is a possibility that software automatically takes a base with respect to that it is going to print, but the user is going to find that which from which side which is going to be print by the printer, because it actually it actually saves time for making these changes also.
JP sir? I think he is disconnected. हाँ, again joined back sir. He got disconnected. Join कर रहे हैं सर. So due to connectivity issue, we could not able to join back sir.
So no issues.
हाँ,
As
again
many as
join.
joined.
I think.
Yeah.
हाँ
Hello.
हाँ JP sir. हाँ JP sir.
Actually, some due to network glitch, I am disconnected, so I am sharing my screen again. Okay. So I'm just telling you that while creating any component in 3D printing 3D modeling software, you have to save a STL file because the 3D printers are accepted this different file format. So whatever 3D printing software you have to check that what extension file it is accepting. Okay, the software which we have is accepting a STL file. So while creating these parts in our 3D modeling software, we save our in STL format. Okay. Now, while placing this component, you have to make sure that you have to place as per your need, because you can see over here, if I am going to change an angle of this component for placing this component, the time which is going to be consumed by the software is going to be reduced. So software automatically takes a particular home position. With respect to that, it places that part in a 3D model 3D printing software. So it depends on you that how you can reduce the time also, and by placing such a
There is some
component
issue
in
of
such a manner. Yes.
voice. जयप्रकाश वॉइस नहीं आ रही है.
Okay,
So
okay sir, okay. सर आवाज नहीं आ रही है मेरी?
सर हमें
आ रही
ऑडिबल हो
है.
रहा था.
It's audible, sir.
दोबारा
Okay ma'am.
share कर दो.
So it okay, so it depends on you that how you can save your amount of material and time which is consumed by a 3D printer to print a particular part. Okay, so after this we print each and every part with the help of 3D printers, and then we assemble and we put a different servo as per our need. Uh, so we have this 3D printer in our campus which has a capacity with respect to a dimension of 300 millimeters in XYZ, with the help of this 3D printer, we printed each and every part of our robotic arm, and this is the final result which we got after creating an assembly. Uh, I'm also sharing a small clip which we created at the same time, which performs a rotation. That actually that time we create a trial, so this is not completely showcase you. So basically the trial model we okay. So this is all from my side, uh, with theoretical which we use modeling and our robo analyzer we use for calculating the position with the help of a robot. The coding part and with respect to the UI we use for robotic arm we shared the answer. So if anyone had any query regarding patients, you can or drop.
सर कह रहे हैं वॉइस वॉइस नहीं आ रहा है.
मैम सुजाता मैम,
हाँ सर.
मैम मेरी तरफ
सर
से भी एंड हो गया. इफ एनीवन हैड, अच्छा मैम सर दोबारा ज्वाइन कर सकते हैं ना तो शायद आ जाए.
हाँ 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 दोबारा ज्वाइन कर सकते.
So this is all from my side. If anyone had any query, you can ask.
सर को एक बार चैट बॉक्स में लिख दो, है ना, एक बार रिकनेक्ट कर लेंगे.
Okay मैम. Sir is actually trying to reconnect, I think.
हाँ जी.
सर आवाज आ रही है अभी? सर Sir, am I audible to you? सुजाता मैम,
सर को मुझे लगता नहीं ऑडियो आई, है ना.
जी मैम.
तो उस दिन भी मैम मीटिंग में ऐसे हुआ था, फिर दोबारा सर
लेकिन सर ने 2 बार ज्वाइन कर लिया।
ज्वाइन कर लिए सर शायद,
मैम सर ने ज्वाइन तो कर लिया है।
मगर आवाज नहीं आ रही है।
नहीं,
अच्छा सर, हाँ दोबारा सर एक बार ट्राई कर दीजिए। अभी दोबारा सर रिजॉइन कर रहे हैं।
सर आवाज आ रही है अभी आपको?
अनम्यूट सर ने करा नहीं।
बट सर
योर वीडियो इज ऑन।
श्रुति मैम लिख रही है।
मोबाइल में सर ट्राई कर रहे हैं कनेक्ट करने के लिए।
मैम कनेक्ट तो सिस्टम से हो रखा है सर का।
ये अभी ट्राई कर रहे हैं दोबारा।
अनम्यूट मेरे ख्याल में नहीं कर रहे क्या सर ने?
मोबाइल से भी सर ने ज्वाइन कर लिया।
हाँ मोबाइल से।
सर आप 2 चीजों से ज्वाइन हो गए, सिस्टम से भी और मोबाइल से भी। आपका माइक म्यूट है सर, तभी आवाज नहीं आ रही आपकी।
नहीं मतलब आपकी आवाज नहीं आ रही।
अभी आ रही सर आपकी आवाज।
सर आप एक सिस्टम से पहले लीव कर दीजिए तो आपका एक को नहीं होगा पहले तो। हाँ सर, सर आवाज आ रही है अभी आपको?
अभी नहीं आ रही है अनम्यूट।
सर आपका माइक म्यूट है।
आवाज आ रही है अब। चल
ठीक है सर। Sir, at last what I shared that if you while printing any component with the help of these 3D printing softwares, the user is that user have total control with respect to placement of a component in any manner. While placing any component, software actually place places that component at the home position. I am going to show you again. I am going to delete this part and placing another component. Suppose this is a gripper base. So over here you can see that the software automatically places that part and show as that it takes around 1 hour 27 printing this component. But while placing this component, actually it takes lot of supports. That's why it such amount of time. Over here you can see that the blue color things are is related to the support. If we are going to change the orientation of this component, the amount of time which is consumed by that component is going to be changed. So you can see over here, if I'm going to rotate this part by 90, so the software again recalculates the amount of time. So you can see that the total amount of time which is around 120 minutes, now it takes around 1 minute. And also it saves amount of material. So while printing any component, you have to check that which orientation saves your time and amount of material which is consumed by your 3D printer to give the final product to you. Okay. So at last, we created this robotic arm, and with the help of Vijay Gill sir, we automate this robotic arm performing a particular task of picking and placing. I also prepared a video at the time of trial. So this is basically the trial video which we created. Due to lockdown, we are unable to showcase you the complete final video. So this is the robotic arm which we created after assembling the different servos, and with the help of different connections, with the respect to a mobile, with the help of a mobile that we created that will be wireless. So we created this robotic arm with the help of 3D modeling software, with the help of our Kia 3D printing software, and with the help of 3D printer. And the final output is this. So this is all from my side. If anyone had regarding the mathematics which we which I shared or the video I shared you, you can ping us through mails also. We are also running a brief webinar in physical mode as COVID-19 situation resumes. For showcasing you how you can use this software calculating the accurate position of your tool, or with the help of this software, MIT Arduino softwares, how to automate your robotic arm that you need. So this is all from my side. Over to you, Sujata ma'am.
Thank you, sir. Thank you, Vijay Gill sir and JP sir, for conducting a very wonderful session. Really, it was an informative session. I do hope all the participants must have gained technical insights from this robotics and automation session. Now, I would like to request Dr. Suti ma'am to share her feedback about the webinar. Over
Yeah,
to
thank you, Sujata ma'am. Thank you, Sujata ma'am.
आपके वो
So
सवाल का
as
जवाब नहीं है
हाँ जी
आपके वो सवाल का जवाब नहीं है कि 6 रोज
अच्छा वो वो भी आ जाएगा इनसे विजय ने शायद देखा नहीं होगा सर we'll get back to that also. So as Sujata ma'am was saying, seriously, the session conducted today on introduction to robotics and automation, it was very, very informative. And they had very nicely divided the session in 3 sections. The first session taken by Mr. Vijay Gill on familiarization with Arduino Uno and this application of MIT App Inventor was very interesting, and it gave insight on the coding. And I know it is very difficult to understand the basics to the T using this online mode, and with how difficulty Vijay was doing that, because Vijay and Lokesh in our department had taken these sessions on coding, this MIT App Inventor and Arduino. And the coding part is really, I mean, you have to have a proper hands-on training to be able to do that portion. But very nicely and briefly, he tried to explain that part. But I hope once we meet, we can do the hands-on session and get into the property of it. The other session taken on introduction to robotics by Mr. Jayaprakash was very educative, very mathematical, hardcore mathematical. And he got into the, I mean, in-depth of different manipulator joints, wrist configurations, and mapping and analysis of principal axis rotation, and very deep mathematical concepts of it. It was very informative because we had never studied that mathematical aspect of it. Generally, we always go through go through only the introductory part of robotics, see what is robot, but the actual working depends totally on this mathematical aspect of it. And the third and most importantly, the session on 3D printing, which is a need of the hour for each and every department. Each and every one of the department should have the understanding of this 3D printing, because only then we'll be able to come out with the good products what we desire. So as rightly said by VC sir number of times, that only by collaborations of various departments we'll be able to achieve what we plan to design and develop. And first step was taken by this mechanical and electronics department by coming up with this hardware of robotic arm that our department collaborated with mechanical, and they came up with this prototype in a working condition that was very appreciable by Vijay and Jay Prakash sir. And it was a really commendable job done by both of them. Thanks a lot for the session. Thank you very much. It was a very, very informative session.
Yes, Sujata.
Are you there, Sujata ma'am?
Sorry.
Oh,
Thank you so much, ma'am, for your kind support in conducting this webinar. Now, I would request Honorable Vice Chancellor, sir, to share his feedback and suggestion about the webinar. Over to you, sir.
सबसे पहले तो मैं विजय कुमार और जेपी शर्मा को कंग्रेचुलेट करना चाहूंगा, जिन्होंने बहुत अच्छे तरीके से अपनी तरफ से कोशिश की बाकी लोगों को भी समझाने की, and how what is robotics and how it works and how different systems have to be integrated in order to make it happen. I was taken back when I was doing my PhD at IIT Kanpur, and my guide was among the first people in the country to talk about robotics. और उन्होंने एक conference भी robotics पर की थी in 1984, I remember. And at that stage, क्योंकि मैं स्टूडेंट था तो बहुत सारे काम हमसे कराते थे, तो उस समय समझ में आया कि ये कितना इम्पोर्टेंट है. And then when the conference was there, the people who were in the forefront of making these robots, उस समय वो उनको बुलाया गया था. They came. Some of the factories जापान से कई लोगों से कोलैबोरेट किया था, तो उन्होंने अपने प्रोडक्ट्स लाए थे, and they had shown lot of videos on this. And मुझे बहुत अच्छा लगा कि आज उस जर्नी को आप लोगों ने फिर से वो रिवाइज सा किया. And the journey which started, the first word robot, which was given by that Karl Kapek in 1921 in one of his novels. उस नॉवल में उसने ये दिखाया था कि एक मैकेनिकल आदमी बनता है जिसका नाम वो रोबोट रखता है, और वो सभी लोगों को अल्टीमेटली मारता है. वो आउट ऑफ कंट्रोल हो जाता है और वो सबको मारता है. That was in 1921. But in 1942 एक आइजैक इसमो था जिसने फिर 3 laws of robotics कहे थे, जिसमें ये कि सेफ्टी किस तरीके से होगी ह्यूमन की, वो एक इम्पोर्टेंट एस्पेक्ट हो गया जो कि बहुत इम्पोर्टेंट था फ्यूचर डेवलपमेंट ऑफ रोबोटिक्स के लिए. और द फर्स्ट रोबोट एज वाज सेड वाज यूनिमेट, व्हिच वाज इन 1950. लेकिन जो प्रोडक्शन में यूज किया गया था, जो इन्होंने भी कहा 1969 में जनरल मोटर्स ने वो यूज किया. But when we look at the journey of robots, the history, how it has developed over a period of time, we have reached Mars. हमारा इसरो ने या नासा ने बिल्कुल वो जो मार्स तक हमारे ये भेजे हैं अपने शटल्स, वो वहां पर किस तरीके से वो उनके पार्ट्स खुलते हैं, कैसे वो मूव करते हैं, वहां पर कैसे उनको एनर्जी मिलती है. All this has developed over a period of time, and the robotics which we saw in 1980 or 60s में is completely transformed. And now it is not only the जो एक सिस्टम बनाया और उससे काम कराया, but now the people are also looking at what is the science behind each and every aspect of. So when you look at the mathematics which was taught, which is basically the kinematics part of it, जो कि हम नॉर्मली इंजीनियरिंग मैकेनिक्स में भी यूज करते हैं, पढ़ाते हैं, जहाँ हम यूलर्स कार्टेशियन कोऑर्डिनेट्स और उस तरीके के पोलर कोऑर्डिनेट्स में काम करते हैं. तो वहां पर भी हम इन चीजों को पढ़ाते हैं मैकेनिकल इंजीनियरिंग में, बट दैट इज व्हाट इज द बेसिस। इससे भी आगे हम चले गए हैं इनफैक्ट, वो ये है कि जब हम आर्टिफिशियल इंटेलिजेंस की बात कर रहे हैं, नाउ हाउ डू वी ऑप्टिमाइज थिंग्स, हाउ डू वी मेक दीज थिंग्स हैपन, जो कि खुद ही ऑटोमेटिकली करेक्शंस करेंगे और अपने पाथ को डिफाइन करेंगे to minimize energy, minimize time, all those things are happening. And the systems which were earlier very crude systems, pneumatic systems, hydraulic system, electrical system, or electronic systems with development in VLSI and all such type of things, they have really become very, very sophisticated. And above all else, now there are many things which are software driven, and therefore मैं इस वेबिनार में एक चीज जो मिस कर गया वो था कि कंपोनेंट जो सॉफ्टवेयर है, जो कि विजय ने ट्राई करने की कोशिश की, वी शुड हैव कंप्यूटर साइंस डिपार्टमेंट आल्सो एसोसिएटेड विद सच टाइप ऑफ एक्टिविटीज, सो दैट ये एक कम्प्रिहेंसिव और एक होलिस्टिक सिस्टम की तरह काम करता है, विच इज वेरी वेरी इंपॉर्टेंट. Today, when we look at robots, they are they talk about human interface, how humans interact with robots. उनकी gestures से पता चलता है कि robot अपनी corrections करते हैं. So all this is the artificial intelligence जो आई है, जिसकी वजह से ये सारा field ही in fact has gone beyond anybody's imagination actually. And therefore we need to, agar humko ye dekhna hai, we need to really come together, work together as a team. Alag alag isolation mein kaam ho hi nahi sakta hai. We have to break these walls, and therefore jab hum wo karenge, we'll be in a position to get best out of all these things. Otherwise hum apne apne choti choti cheezein dekhte rahenge. विजय अपना सिर्फ वो पार्ट देखेगा कि मैं इसको एंड्रॉइड से कैसे कनेक्ट कर रहा हूँ, ये अपने हिसाब से देखेंगे कि मोशन कैसे हो रही है, सॉफ्टवेयर वाले अपने हिसाब से देखेंगे कि क्या हो रहा है. बट इफ वी कम टुगेदर, देन एंड ओनली देन we will be in a position to talk about the future entrepreneurs, develop our students into entrepreneurs who will be ultimately responsible for developing these robots, not only as the mechanical tool, but which have the electronics part and which has the software part of it. So therefore, this software and hardware has to be put together. और अगर हम उसको वो नहीं करेंगे तो हम कहीं ना कहीं बहुत पीछे रह जाते हैं इस चीज में ये करने से कि एक होलिस्टिक अप्रोच जो है वो नहीं रहे. So when we look at the mechatronics, I look at it, all the three put together can make these systems much better. If you look at this system which went to Mars or which goes to moon आजकल, तो ये सारे किस तरीके से different, it is not the electrical energy now it is the solar powered system जो कि वहां पर भी उसको energy देते हैं. Now how do we design them, how do we integrate them? So therefore all these things, whether it is material, whether it is energy, whether it is the electronic part of it, whether it is software, all of this has to be seen together actually. And ये तो जो आज आपने किया वो बहुत अच्छी बात है. At least we have started integrating it, we have started coming together, we have started understanding that what are the issues which are important, and everybody says that 3D is becoming very important, and you have tried to show that how we can develop these systems will become important. When we look at these robots today, we are looking at robots कि वो एक डोमेस्टिक हेल्थ की तरह भी हमें काम करेगा, वो हॉस्पिटल्स में किस तरीके से काम करता है. हियर यू हैव ऑल्टो, एक वो था, आई थिंक जेपी वाज विद अस दैट डे and we went to that factory. They had more than 600 robots working in one place actually. So therefore medical में surgery is done by robots. अगर हम देखेंगे गेम्स में बहुत जबरदस्त रॉबोट्स का है. रॉबोट्स फुटबॉल खेल रहे हैं, हॉकी खेल रहे हैं, चेस खेल रहे हैं. सो देयरफॉर दीज सिस्टम्स व्हिच automatically pick up कि क्या हो रहा है, which I would consider more like autonomous robots, which are very, very important and have become part of our life actually. So the factories of future जिसकी बात कर रहे हैं या स्मार्ट मैन्युफैक्चरिंग की बात करेंगे, तो उसमें तो आर्टिफिशियल इंटेलिजेंस, मशीन लर्निंग has become an integrated part of it. So what today we looked at was the beginning part of it, what is given to the beginners. We now need to move to the next level, which is intermediate level. And the third one is the advanced level, जहाँ हम research करें, जहाँ हम develop करें, जहाँ हम theories दे दें, उस stage पर हमको आना है. अगर हमको survive करना है और ये दिखाना है कि हम अच्छा काम कर रहे हैं, then we will have to talk about. Look at, आपने वो उड़ी picture सभी लोगों ने देखी होगी, because it was a very nice movie. और उसमें भी जो वो वर्ड जो होता है जिससे कि वो सारी इंफॉर्मेशन उनके कैंप्स की ले लेते हैं, तो दैट ड्रोन विच वाज इन द फॉर्म ऑफ अ बर्ड वाज नथिंग विच वाज हैविंग कैमरा. इस कैमरा से उन्होंने वो डाटा ले लिया. सो डाटा कलेक्शन के बाद उसको एनालाइज किया और उसके बेसिस पर उन्होंने डिसीजन लिया एंड दे उसके हिसाब से उन्होंने स्ट्राइक किया. किस तरीके से हर चीजें इंपॉर्टेंट हो रही हैं. सो देयरफॉर इट इज सिग्नल प्रोसेसिंग, द इमेजिंग किस तरीके से हम करते हैं, देन डिजाइनिंग इलेक्ट्रॉनिक्स फॉर दिस, designing mechanical system for this will become very, very important, and it all is integrated today by the softwares we have. So we have to really work on this. जब हम मैन्युफैक्चरिंग, खासकर स्मार्ट मैन्युफैक्चरिंग, जो सुजाता इज वेरी फॉन्ड ऑफ यूजिंग दिस वर्ड, जब हम उसकी बात करते हैं तो मैन्युफैक्चरिंग इज नॉट ओनली मैन्युफैक्चरिंग, इट आल्सो हैज सप्लाई चेन एसोसिएटेड विद इट. We probably will be required to develop healthcare systems for it. And किस तरीके से हम ये robots खुद ही काम करते रहेंगे और ये होगा. एग्रीकल्चर में, फिनेंशियल सर्विसेज में, एजुकेशन में, पब्लिक यूटिलिटीज में, एनवायरनमेंट में, हर जगह इनकी जरूरत पड़ सकती है और हम इनको यूज कर सकते हैं वेरी इफेक्टिवली. एंड देयरफॉर जो आज किया गया ये शुरुआत थी. आई थिंक वी नीड टू कीप ऑन टॉकिंग अबाउट व्हाट वी आर डूइंग, keep on moving one step ahead further, and I'm sure that over a period of time we will be in a position to say that we are doing a good job, and a job which is required in the society, which will become very, very important. The innovations are required. The innovations have to go and get integrated into all this system, और हमारे सिस्टम इस तरीके बनने चाहिए जो कि सोसाइटी पर इम्पैक्ट कर सकें. If we are in a position to do it, I'm sure that we will be recognized. हमारा काम recognize होगा. We'll be able to produce our students who will become entrepreneurs in these areas. It is not only robot कैसे काम कर रहा है, but then making systems, developing other associated things with it will become very, very important. और मुझे लगता है कि ये शुरुआत है और हम मेरे हिसाब से हर 15 दिन में कोई न कोई अपनी बात करना चाहिए कि मैंने इस एरिया में ये थोड़ा सा आगे बढ़ा दिया है, बाकी इस पर कमेंट करें, उससे हम आगे अच्छा कर सकेंगे, मुझे लगता है. So I was really, it was good to listen to Jaiprakash and Vijay, and I congratulate them for this initiative and hope that Sujata and Shruti will take it forward further and will integrate it with the computer science department as well, which is becoming very, very important, right? So, Delhi, let us hope for the best for future.
Thank you so much, sir. Thank you, sir.
Thank you so much, sir, for your valuable feedback and guidance to us always. Next time, we will definitely try to organize a webinar in collaboration with all engineering disciplines. Thank you all for joining and making it a successful session.
मैं
Thank
तो
you.
इसको ये नहीं मानता हूँ कि सिर्फ इंजीनियरिंग है। मैं तो टुडे जब हम
हाँ जी सर।
टेक्नोलॉजी की बात कर रहे हैं तो वो तो किसी के साथ भी, वेदर इट इज एजुकेशन, वेदर इट इज एनी अदर एरिया, हॉस्पिटल्स हैं, आपका डेंटल हॉस्पिटल है, ये मतलब इट हैज एप्लीकेशन एवरीवेयर। सो देयरफॉर यू हैव टू इंटीग्रेट विद अदर्स आल्सो, गेट देयर ओपिनियन, और मुझे लगता है कि वो एक अच्छा चीज हो जाए।
Okay, sir. Multidisciplinary.
Absolutely, that
Absolutely,
approach
sir.
has
Absolutely. Thank you so much, sir. Thank you.
Thank you.
Thank you. Thank you, sir. Thank you, ma'am.
Thank you, ma'am. Thank you, sir.
Thank you, JP.
Thanks
sir.
again, Vijay and JP, sir. Yeah, that's what I said.
Thank you.
Okay, ma'am.
Okay, bye.